So hi everyone, I'm just going to wait a little bit longer for more people to come in, anyone who's not in just yet, and then we'll get started. Okay, so hi everyone, and welcome. For those of you who don't know me, I'm Evelyn. In yesterday's session, we had a look at solving linear equations. Today, we're going to do a little recap on solving linear equations, and then we're going to move on to simultaneous equations. And for anyone who wasn't here yesterday, we also have a session tomorrow, and that will be on quadratic equations. So someone's already asked me a question, are we doing a Kahoot today? Yes, we will be doing a Kahoot at the end of the session. And I think quite a lot of people are in already. So let's get started with the recap. One thing also that I'd like to point out, anyone who has any questions, try and keep it in the Q&A so I can see your questions. And when I'm asking you questions and you're giving me the answers to questions, put them in the chat. So brilliant. Questions in the Q&A, answers in the chat. So the recap. So yesterday we had a look at solving linear equations. To remove a number or to get rid of something on one side of the equal sign, remember you have to do the inverse operation on both sides. When there are x's on both sides, look for the smallest x and move it, which makes the equation easier to solve. Because remember yesterday we talked about how it lets you calculate answers without so many negative signs in there, so it makes it a little bit easier. And when one side of the equal sign is a fraction, to get rid of that denominator, you can multiply both sides by that denominator so that you've got whole number terms on both sides, which is a whole lot easier rather than using fractions when solving, because you're more likely to make mistakes. So we're going to go through a quick recap question. This is sort of similar to the problem solving question we went through yesterday. What I would like is I would like everyone to have a go at answering this, and to have a read of it and then have a go at answering. And I'd like you all to put your answers in the chat and not the Q&A. Leave the Q&A for any questions that you have. So no problem if you have forgotten how to do it, we will go through it in a second. But have a go if you do sort of have some sort of idea how to work it out. Brilliant. So I'm seeing some really good answers here. So someone asked, is it the same when you get given the equation? Well, in this situation, you have to form the equation and then solve it. So if you know what the equation is, then yes, it's going to be the same as when you're given and you solve it. Yeah. So we're going to start going through it now. Let's have a go at this. Let's get the pen. So first of all, it says last week Comet ate X carrots. So that's Comet. Dasher had twice as many carrots as Comet. Now, twice as many of x carrots is just 2x because it's 2 times x, yeah? And then Rudolph had 3 less carrots than Comet. So that would be the number of carrots Comet had minus 3. Now it says altogether, the 3 had 57 carrots. So if I add all of these together, this should give me 57. So this is sort of similar to what we did yesterday. Form the equation first, and then we're going to simplify it and solve it. So when we simplify it, we've got 1x, we've got a 2x, and we've got another x. So we can collect those like terms. That will give us 4x. And then we've got our minus 3 equals 57. Now we've got an equation which looks just like some of the ones we did yesterday. So we can go ahead and solve it by first adding the 3 on both sides. So we've got 4x equals 57 plus 3, which is 60. And then the last step is to divide by 4 on both sides. So on the left-hand side, we get x, and on the right-hand side, we have 60 divided by 4, which is 15. Brilliant. So we know x is 15. Now Comet x caret, sorry. So Comet had 15. Dasher had twice as many. So Dasher had 2x, so that's just 30 because it's 2 times 15. And Rudolph had 3 less than Comet. So it's just 15 minus 3, which is 12. So brilliant for anyone who got those answers, and hopefully everyone understands it now. Let's move on to what we're doing today. So that was yesterday's recap, but today we are going to have a look at solving simultaneous equations. Now it links in a lot with solving linear equations. So the different things that we'll be doing today is solving the standard simultaneous equations that usually come up in your maths exam. So that's with 2 linear equations. For the higher students only, so the students who are only taking the higher exam, we will have a look at solving the harder simultaneous equations with 1 linear and 1 quadratic equation. And then lastly, for everyone, we're going to have a look at forming simultaneous equations and solving them. So sometimes you get problem solving questions with simultaneous equations. So we will have a look at that as well. So simultaneous equations. A simultaneous equation requires algebraic skills to solve them, and it consists of 2 or more equations. Now, they are called simultaneous equations because you solve them at the same time. So an example of what a question might look like, it might look like this example below. So you've got 3x plus y equals 11 and 2x plus y equals 8. So you've got 2 linear equations, and then you're asked to find what is x and what is y for each of those equations, and they should work for both. So it's always good to check your answer at the end. Once you figure out what x is and what y is, make sure you put them into both equations to make sure that they work. Now, if we have a look at this now, so to solve those type of equations, we solve by elimination. This is one way of solving it. You make either the x or y coefficients the same. A coefficient, so I've got what a coefficient is up here. So a coefficient or coefficients are the numbers in front of the letters. Like say if you had 2x, the coefficient of x would be 2. So that's just the number in front of the letter. Now, once you've made either your x the same or your y is the same, then you either have to add or subtract the equations to make sure that you eliminate that letter. And then you solve the equation that you get, you solve for either x or y, and then you substitute that value back into one of the original equations to find the other letter. Now, some of you might have done it before, some of you might not have. So what we're going to do is we're going to go through an example together, and then I'll let you have a go by yourselves to see whether you do understand it. So we're going to go back to that same equation that we just saw as an example. I'm going to change the color of the pen. I'm going to zoom in a little bit as well so everyone can see it. Right. So this is a typical example of a simultaneous equation question that you could get in your exam. Now, remember, the first step is to look at your x's and your y's. Look at the numbers in front of them. Is one of them the same? So if we look at the x's, we've got 3 and we've got 2. Those aren't the same. But if we look at the y's, remember in algebra, there's like this imaginary 1 in front of your letters. So our y's are the same. There's no different numbers in front of them. So that's the first thing done. The next thing, I have to remember to either add or subtract because I want to eliminate them. Now, in this case, I'm going to subtract them because y minus y gives me 0. I want to eliminate one of my letters so it's easier to solve. So I'm going to do the top equation minus the bottom equation. So we've got 3x minus 2x. 3 minus 2 is just 1, so we get 1x, and we write that as just x. Then we've got y minus y. Well, that's just going to be 0, so we don't even really need to write down plus 0 because it's just nothing anyways. And then we've got our equal sign, and then we've got 11 minus 8. Now 11 minus 8 is 3. So we know that x equals 3. That's the first thing that we know. Now to work out what y is going to be, we take x equals 3 and we're going to substitute that back into one of the equations that we had in the beginning. So I'm just going to take the first equation. So if I write it up here in a different color, we've got 3x plus y equals 11. I'm going to substitute x equals 3 into this equation. So I've got 3 times 3 plus y equals 11. So 3 times 3 is 9. So I've got 9 plus y equals 11. And remember, to solve, you want to get y by itself. So I'm going to subtract 9 on both sides to get rid of that 9. So I'm going to have y equals, and then 11 minus 9, which is 2. So this would be our answer. X equals 3 and y equals 2. So some of you, I can see in the chat, you did get that. Brilliant. Perfect. So hopefully that makes sense. A little trick, which I would like to sort of point out as well. Sometimes students find it difficult to know whether to subtract or to add the equations. If the numbers in front of the letters have the same sign, you subtract. If they have the opposite sign, let's say one was positive, one was negative, you're going to add the two equations together. So using this tip, and I've got this tip in the bubble at the top over here for you to help you guys as well when answering this one. I'd like you guys to have a go at answering this question, and I'll zoom in a little bit as well for you to see it a bit easier. So look at the numbers in front. If they are not the same, you might have to multiply one of the equations by something, or even both of them by something, to make sure that those numbers in the front are the same. Once you've made them the same, you're either going to add them or subtract them, and depending on what the signs of the numbers are, and then solve it. So I'd like you guys to have a go at that for me. Someone asked, what will we be learning tomorrow? We'll be going through quadratic equations tomorrow. So that'll be something to look forward to. So these courses are only for the 3 days. Tomorrow is the last session. So I'll just wait a little bit longer for everyone to have a go at answering this. And if you are stuck, don't worry, I will go through it in a second. Tomorrow is not only for higher students, it's for both higher and foundation students. Just like today, there will be some parts of the session which are for higher students, but in general, everyone can show up to the session because it will be beneficial for everyone. There's something for everyone there. So someone asks, can you make X the same? You can make either the x is the same or the y is the same. It's completely up to you. So the sessions are for anyone in year 10 and anyone in like working towards level 6 to 9. Bear in mind, everything that we go through is for higher students. There's only certain things which are in it in these sessions which are only for higher students. So whether we're doing something quite simple or we're doing something quite hard, higher students need to know everything that I'm going through. So it's not only it's not just easy things that we're going through or just things for foundation students either. So we won't necessarily be going through substitution by itself, but there will be parts in this session, in today's session, and maybe a little bit tomorrow's session, which does include substitution. And a lot of you are asking, is y a fractional value? Is y a decimal? And we're going to go through it now. So let's have a look at this equation then. So we've got 3x plus 2y equals 16 and 2x minus 3y equals 2. Now, what I'm going to choose to do, I'm going to make x's the same. So I need to think of a number that both 3 and 2 go into, and the first number I can think of is 6. So to make 3, to turn 3 into 6, I can multiply that 3 by 2. Now, if I multiply my 3x by 2, I have to multiply the entire equation, that top row, by 2. Now, because I'm going to make that 6, I need to make my bottom equation, I need to make that 2x 6x as well. So to get from 2 to 6, I need to multiply by 3. And again, I have to multiply that entire row by 3. So if I multiply the first row by 2, I get 6x plus 4y equals 32, because 2y times 2 is 4y and 16 times 2 is 32. And then the bottom row, I've got 2x times 3, which is 6x. And I've got minus 3y times 3, which is minus 9y. And then I've got 2 times 3, which is 6. Right, so the next thing to do is to figure out, am I going to add these two equations or am I going to subtract the two equations? Well, because I made my x's the same and they're both positive 6, they're both the same sign, I need to subtract my two equations. Now 6x minus 6x is 0. 4y minus 9y, because I've got two negatives there, that turns into a plus. So it's going to be 4y plus 9y, which is 13y. Because remember, it's 4y minus 9. Minus 9y. And then I've got my 32 minus 6, which is 26. So the last thing to do to solve this is to divide both sides by 13. So I've got y equals 26 divided by 13, which is 2. So y was not a fraction or a decimal. Y is a whole number. Y is equal to 2. Now the last thing to do, I know that y is 2. I now need to substitute that into one of my equations. So if I choose the first equation, I've got 3x plus 2y equals 16. I can substitute y equals 2 into that. So I've still got my 3x, but then I've got 2 times 2. Now I put them into brackets just to make it easier to see what to do first, so I don't make any mistakes. So I've got 3x plus 4 equals 16. And then I can subtract 4 on both sides. So continuing to solve, just like we did yesterday. 16 minus 4 is 12. And then I divide both sides by 3. So I got x equals, and 12 divided by 3 is 4. So x equals to 4. So my answer would be x equals 4 and y equals 2. Now, for those of you who might, if I zoom out a little bit, for those of you who are very close to getting the answer, but not quite there yet, what I encourage everyone to do is once you get your answer, x equals and y equals, pick whichever equation you didn't use. So remember, I used this top equation to substitute y equals 2. I would like you to pick the other equation that you didn't use. So that would be 2x minus 3y equals 2. And put those two values, your x equals 4 and y equals 2, into that equation to see whether you get the right solution. If you don't, then you know that you've done something wrong along the way. But if you do get the right answer, then you know that you're correct. Yeah. Now, someone asked what grades are these questions worth? So this question, I think, is around a grade 5. But the question that we're going to go on to in a second is worth probably a grade 7, I would say, because it includes not just linear equations, but quadratics. And I'll go into that in a second. Someone asks, did you subtract the equations? Why did you subtract the equations if the signs are opposite? So in this bubble at the top over here, if the signs are opposite, then you add, you don't subtract them. But if they are the same sign, then you subtract them. The whole point is to make sure that you eliminate that letter. So if you've got, let's say 6x minus 6x, that gives me 0. So I've removed my x's. That's the whole point. Can we also use the equation that we used? You can, but you're not really checking whether you got it correct or not, because you've already used that to substitute to find x. So you're not really checking whether you got it correct. You're just double checking whether you got the right x for the y that you got. I would always say use the other equation, because then that will really tell you whether you've gotten the question right or not. Right, let's move on. Just for time's sake, I will answer any questions that I see along the way, but just for the sake of time, let's move on. So this is only for higher GCSE students, and this does not come up in the foundation paper, only the higher paper. So just to make it clear for those of you, if you are studying foundation and you are in the Zoom today, for higher students, you need to know how to solve simultaneous equations when you have a linear equation and a quadratic equation. So the first thing to do is a little bit different from solving by elimination. Instead, we're going to solve by substitution. So we're going to rearrange the linear equation so that either x or y is the subject of that equation. And then we're going to substitute this into the quadratic equation. And then you solve your quadratic equation for either x or y, and then you substitute your solution back into one of those original equations to find the other letter. So that last step is just like the last step that we just did. The only thing that changes is the first part. We're not solving by elimination, we're solving by substitution instead. So we're going to go through an example together. So let's have a look. This is what these harder simultaneous equations look like. So the top equation is a quadratic because we've got an x squared in there. The bottom one is just a linear equation. So we're going to go ahead and solve this using the method of substitution. Now, if we have a look at our linear equation, which is this bottom one, it's already got y as the subject of the equation. What I mean by the subject of the equation is that y equals, and then everything else is on the right-hand side of that equal sign. Now, because y is the subject, I can now substitute this into the first equation. So if I write it out for everyone to see, the first equation is y equals x squared plus 2x minus 14. Yeah. Now, I also know that y equals x minus 2. So I'm going to take my x minus 2 and substitute that for my y in the first equation. So it's going to be x minus 2 equals x squared plus 2x minus 14, because y equals x minus 2, yeah? And now I'm going to set my equation equal to 0 and then solve my quadratic equation. One thing I like to point out now, which I'll also point out tomorrow when we go through solving quadratics, always make sure when you're solving quadratics, your equation equals to 0 first. Otherwise, you can't solve it properly. Yeah, so we're going to set this equal to 0. And to do that, we need to move our x and our -2. So that means I need to add 2 to both sides. So I'll start with that first. So I've got x equals x squared plus 2x minus 14 plus 2. And minus 14 plus 2 is minus 12. And then I can subtract x from both sides. So I'm left with 0 equals x squared plus 2x minus x minus 12. And 2x minus x is just plus x, because 2 minus 1 is just 1. Yeah. And then we will go ahead and solve for quadratic equation. Now, there's loads of different ways to solve quadratic equations. The way how I'm going to show you right now how to solve this is just by factorizing. So I need two numbers that multiply to give me -12, and they add to give me a +1. And then I'll put them into brackets. If you're a bit confused about this step, don't worry. We will definitely go through this tomorrow. So don't worry if this step sort of confuses you a little bit at the moment. I'll make sure that I go through it properly tomorrow. Now, two numbers that multiply to make -12 would be -3 and 4, because they also add together to give me +1. So if we check that, we've got -3 times 4 gives me -12, and -3 plus 4 gives me 1. So I can put those numbers into my brackets. And then finally, to finish off solving it, I'm going to use a different color for a second. To finish off solving it, I take each bracket and I set it equal to 0. So I've got x minus 3 equals 0 and x plus 4 equals 0. So x is going to be equal to 3 and x equals to -4. Now, a lot of students, because they think this is a lot of working out, they leave this as their answer. They lose about 2 marks when they do this. The reason why is because it's a simultaneous equation, meaning that you have to work out what your values of x are going to be, but you also have to work out what y is going to be as well. So you use, just like the other simultaneous equations, you use your answers for x and you substitute it into one of the equations to work out what y is going to be. The easiest one to use is the linear equation. So when x is 3, y is just going to be, if we use that second equation, y equals x minus 2, y equals 3 minus 2. So y equals 1. And then when x is -4, y equals -4 minus 2. So y equals -6. Now, the way how to write it, another step which a lot of students sort of miss a few marks for, is the way how you're writing it. So when x equals 3, y equals 1. And when x equals -4, y equals -6. Do not get them confused. If you write when x equals 3, y equals -6, that's not true, because if you put it into the equation, when if y equals x minus 2, y can't be -6 when x is 3. So that would be incorrect, and that's another place where students lose 1 mark from. So always make sure you match up your y's with your x's, because you get more than one solution for both. Yeah. Hopefully, I'm going to zoom out so everyone can see the different steps that I took. It is a lot of working out, and make sure that you write it in a nice structured way so it's easy to see. Someone asked you leave your answers as coordinates. No. Don't leave your answer as coordinates. The reason why is because they want to know what x equals and what y equals. If you're using a graph, however, and they ask you to leave your answer in coordinates, then you would. Someone asked, could this be a foundation question? No, foundation, this does not come up in foundation exam. Only the other simultaneous equations we went through, it will do. just for time's sake, I will continue answering these questions, but what I would like you guys to do is have a go at answering this question while I go through and answer some of these questions. So I'll zoom in a little bit and have a go at answering this question. So for a hint, rearrange that linear equation so that either x is the subject of the equation or y is the subject of the equation, and then substitute. Someone asked, how many marks is this question worth? Well, this question would probably be worth around at least 5 marks, I would probably say. Yeah. It's worth a lot of marks, and to be fair, it would come up towards the end of your higher paper because it takes a lot of time to work it out. It's worth a lot of marks and it's quite challenging. So someone said that usually in the test it comes up as a word problem. I struggle to understand it, so how should I understand it more? Well, that's a brilliant question, because we're going to go through a problem solving question with simultaneous equations in a second. The best thing to do is always form the equation first and then solve it afterwards. Now, word problems usually only come up with the standard simultaneous equation, so only when you have 2 linear equations. So that type of question could come up in both the foundation and the higher paper. And we will go through that in a second, once everyone's had a go. Someone said, will we go through this tomorrow as well? I'm a little confused. No problem. Tomorrow, we won't go through the higher GCSE questions. So we won't go through this particular type of question. We will go through the standard simultaneous equation question that comes up in both papers. But if you are a little stuck, and you weren't too sure about how I've gone through and answered it, and you'd like to go through it again, it is going to be recorded. So have a look out for it on YouTube, because all of these sessions are recorded, so you can always go back and rewatch it if you would like to go through it again. Someone asks, is tomorrow for foundation as well? There are parts for foundation and there are parts for higher, so it's beneficial for both types of students. And someone asked, how did I get rid of y at the start? At the start, we're using substitution. So because y equaled x minus 2, instead of writing y in my first equation, I just wrote x minus 2. So it's a little bit different from the other one. We're not eliminating them, we're just substituting. So it's 2 different methods to solving. Someone asked, why are there 2 values of x and y? That's actually a really good question. The reason why is because it's a quadratic equation. When you solve quadratic equations, you usually get 2 solutions for x. So because you've got a quadratic equation in this simultaneous equation, you're going to get 2 values for x and 2 values for y. It's not always the case, but it is very common for you to get 2 values for x and 2 values for y. Right. So what's the difference between the higher and foundation paper? The foundation paper only has topics from levels up to level 5, whereas the higher paper has topics from all levels, so from level 1 all the way up to level 9. So that's why I was saying some of you were saying that it should only be for a certain level, but it's actually for every single level. So you need to know everything, not just what the foundation students need to know, but also some extra topics as well. Someone asked further maths. Further maths is different. It's a different specification. If we're talking about further maths GCSE, it's a different specification. So you not only need to know the stuff in GCSE, but you learn completely different topics from normal GCSE. So that's completely separate. Right, I'm going to start going through this question just so we have enough time to finish off the other things that we have left to go through today and our quiz. So first things first, I'm going to rearrange this linear equation. So either x is the subject or y is the subject. Now, to make it easier, in that first equation, I only have one y, whereas I have different x's in there. I have an x squared and an x. So I want to really rearrange my second equation to make y the subject so that I can just substitute it in once and it'll make it easier and I'll make less mistakes. So to make y the subject of the equation, I can get rid of that x, so I can subtract x on both sides. So I'm left with minus x minus 4 equals y. Now I'm going to substitute in minus x minus 4 into that first equation. So I've got minus x minus 4 equals x squared plus 6x plus 6, because remember y equals minus x minus 4. So I've just replaced my y with those values. Then I'm going to rearrange it to make 0 the subject. So I get rid of everything on the left hand side basically and move it onto the right hand side. So I'm going to add 4 to both sides first. So I'm left with minus x equals x squared plus 6x, and 6 plus 4 is 10. And then I'm going to add x to both sides to get rid of that minus x. So I've got 0 equals x squared plus 6x minus x plus 10. And 6x minus x is just 5x. And then you need to go ahead and solve. So you need to think of, there's more than one way of going ahead and solving this equation. You can either think of two numbers that multiply to make 10 and add to give you 5, or you can go ahead and solve a little bit of a different way. So I think someone said, why do you add x? The reason why is because I've rearranged it, I've got minus x minus 4. So if I want to move that x onto the other side, I need to add, oh, sorry, yeah, you're absolutely right. I've made the mistake. You're absolutely right, sorry. See, everyone makes mistakes. Right, we add x. Thank you for pointing that out, guys. So we're going to get 7x instead. Sorry for making that mistake. So we've got x squared plus 7x plus 10. So this makes it a little bit easier to solve now. So two numbers that multiply to make 10 and add together to make 7. So I'm going to get my two brackets again. And again, if this is a little bit confusing, we will go through it again tomorrow, because it's just solving quadratics. But two numbers that multiply to make 10 and add together to make 7 is 2 and 5. So we've got these in our brackets. We set each bracket equal to 0. So we've got x plus 2 equals 0 and x plus 5 equals 0. So then x equals minus 2 and x equals minus 5. And those are my two solutions for x. And then I need to work out what my solution for y is going to be. So if I use that second linear equation, I've got minus 4. I'll use a different color for this just to make it a little bit easier to spot. So I've got minus 4 equals minus 2 plus y. If I get rid of that minus 2, I'm going to add 2 on both sides. So I've got minus 2 equals y when x is equal to minus 2. And on the right hand side, if I use that same equation, minus 4 equals x plus y. Well, in this case, x is minus 5. I'm going to add 5 onto both sides. So I've got 1, because 5 minus 4 is 1, equals y. So the way how you'd write it is x equals minus 2, y equals minus 2, and x equals minus 5, y equals 1. So well done for you guys who got that. I think a lot of you did get that answer, which is brilliant. And remember to match up the correct y's with the x's as well. Right, Brilliant. So hopefully that does make some sense. Remember, it is only higher student, any foundation students who are completely lost, don't worry, you don't need to know this for your exam. The last thing which I like to go through before, or the second to last thing I like to go through before we go on to that quiz, is forming and solving simultaneous equations. So someone was talking about worded problems. Sometimes you do get simultaneous equations in the form of a worded problem. The way how to do it is to form the two equations first using the problem and then solve the simultaneous equation as normal. So I'd like everyone to have a read of this and then have a go at forming the equations and solving it. Now, we did sort of go through an example of forming equations at the beginning. It's very, very similar to that. So have a go at this question and then we will go through it. So yeah, some of you are spotting the little theme I've got here, which is good. So someone asks, how many marks would a worded simultaneous equation be worth? It depends how tricky it is, but usually it would be worth maybe around 4 or 5 marks. Like standard simultaneous equation questions are usually worth around 3/4 marks, usually. Yeah. If the normal simultaneous equation was worth 3 marks, then the worded one would just be worth 4 marks because they'd add on 1 mark for you to form the equation and then 3 marks to solve it. No, we're not getting very long questions. I'm not going to put any simultaneous equations with quadratics in the Kahoot. So don't worry about solving really, really long simultaneous equation questions, but there will be a few simultaneous equation questions in general in there. So someone asked a really good question about the higher questions. Will there ever be a simultaneous equation question where quadratic equations need to be solved by the quadratic formula? Yes. There could be quadratic equations which could be solved by completing the square, difference of two squares, factorizing quadratic equation. The point is, as long as it's a quadratic equation that can be solved, no matter which method that you use, you just need to solve it. So it could be quadratic formula if it's a calculator paper, or it could be factorizing if it's a non-calculator paper. As long as you know how to solve it, it doesn't actually matter which method you use. So remember, if there is anything a little bit confusing, remember to, you can rewatch it as well, because it is going to be recorded. Right, I'm going to go through this question now. I can see quite a lot of really good answers there. So let's go through this. So Jack Skellington buys 5 gold rings. So I'm going to say gold rings are X and pear trees are Y, just to make it easier to see how to solve it. So Jack Skellington buys 5 gold rings and 2 pear trees in the shop and a total to make £580. Jack Frost buys 2 gold rings and 2 pear trees in the same shop and they cost £250. So we've got our simultaneous equation here. I formed the 2 equations using the problem. Now I'm going to solve it. Now my y's are the same. I've got 2y and 2y. They both have the same sign. So I'm going to subtract my equations using that hint at the top. So 5x minus 2x is 3x. 2y minus 2y is 0. And 580 minus 250 gives me 330. So solving this, I need to divide both sides by 3. So I get x equals, and 330 divided by 3 is 110. So I know 1 gold ring is £110, and then I need to work out what 1 pear tree costs. So I'm going to take that second equation because it looks a little bit easier than the first one, and I'm going to substitute in my x equals 110 to work out what y is equal to. So I've got 2 times 110 because I've got 2x plus 2y equals 250. And then 2 times 110 is 220 plus 2y equals 250. And then I can subtract both sides by 220 just to get what 2y is equal to. So 250 minus 220 is 30. So the last thing to do is divide both sides by 2. Oops. So y equals 30 divided by 2, which is 15. So brilliant. We've got x equals 110 and y equals 15. But remember, they're asking how much does 1 gold ring and 1 pear tree cost. So a gold ring is £110 and a pear tree is £15. So remember, they're asking how much does it cost. You have to give a unit. Is it pence? Is it pounds? Is it euros? Make sure you put down how much it actually costs and what they are, because if they're asking how much does 1 gold ring cost, you can't say x equals 110. That doesn't tell me how much a gold ring costs. Yeah, so always remember to finish off your questions properly. Now, just before we finish, there is another way that you can solve, or they could ask you how to solve simultaneous equation questions, and it is graphically. We're not going to go through it completely because that relies on going through how to draw graphs, and we're not going to do that today. But the way how you would go and do it is you would draw a set of axes, plot the graphs, and then find the coordinate of the point where the 2 lines cross. So if we have a look at this, if they ask, this is a typical example of how they would ask you to solve graphically. They would say, use the graph on the right to find the solution to the simultaneous equations. So they've drawn the lines for you. All you have to do is find out what is x equal to and what is y equal to. So you find the point where the lines cross, and that's when x is 3 and when y is 1. So your answer would be x equals 3 and y equals 1. And that's how you solve using a graph. Yeah. And then remember, always check your answer. So just put those numbers into the equations to see whether they work. And they do if you have a go at doing it. So just for time, I'd like you guys just to have a go at this one. What would be the solution to this simultaneous equation? Remember, you're looking for the point at where they cross. What is x equal to? What is y equal to? Brilliant. You're all of you are correct. So that point where they cross, that is when x equals 3 and when y equals 2. So it's just x equals 3, and y equals 2. Brilliant. And that is usually only worth 2 marks. The only time when it's worth more is when you have to draw the lines yourself and solve it. And then that would be worth around 4 or 5 marks. The only time when you need to solve using a graph is when they tell you to solve using a graph. That shouldn't be your go-to way of solving simultaneous equations. They ask you to solve a simultaneous equation, and that's the whole question. Use algebra. If they ask you to use a graph, then they'll give you an axis to draw your graph. So don't worry about needing to know when to use a graph or not. It will be very clear. So some tips before we get on to Kahoot. When solving simultaneous equations, remember to get values for both x and y. If the coefficients have the same signs, add them. If they are the same, then subtract. And for higher students, you could be asked to solve 1 linear equation and 1 quadratic equation. It is common for you to get 4 values at the end, so 2 for x and 2 for y. So I'd like you guys to log into Kahoot. Any questions that you still do have on any of these, make sure to put them in the Q&A. I'm going to try and go through the questions as we're going through the quiz. If you guys aren't too sure if you guys can't log into Kahoot, please do still participate. Just put your answers in the chat as we're going through which answer it should be. Someone asked, can you solve quadratic graphs graphically? You can solve them graphically, but you wouldn't be asked to solve them graphically in your exam. Not necessarily, only for, there would be 1 or 2 questions where they would ask you to do that, and we might be able to go through that tomorrow if we have time, but it will be very, very clear if they want you to do that, and we'll have a go tomorrow if we do have time. Someone asked, so we just draw the lines and find where they cross? Yes, simultaneous equations, you just draw the lines and find where they cross. If you are asked to solve them graphically, that is the whole solution. Okay, I'm going to start the quiz just for time's sake. It is in the chat and the code will be at the bottom of the screen if you're not yet logged in. But we will get started now. True or false? When solving simultaneous equations, you should first make the coefficients of x or y the same. This is for general simultaneous equations, not for the quadratic ones. Right, brilliant. It is true. So remember, when you are solving the standard simultaneous equation questions, you want to make sure either the coefficients of your x or y are the same, so you can either add or subtract. Brilliant. Well done for the top 5. Right. What is the value of x? So have a go at trying to solve this simultaneous equation. Everyone has 2 minutes, so you don't need to rush it. But what should the value of x be? So someone asks, how do you get rid of the square of x? Well, when you are solving with a quadratic equation and a linear equation, you don't get rid of the x squared because you have to solve by substitution. So you substitute the linear equation into the quadratic equation. You can't solve by elimination, so you can't add or subtract those equations because you have that x squared. So always remember there are 2 different ways of solving those types of equation. Elimination for the standard ones, substitution for the quadratic ones. So someone asked another good question. Will you get a question with both a quadratic and a linear in one single question? So for the higher students, those harder simultaneous equation questions, you will only get one quadratic equation and one linear equation. It won't be any more than that. You won't get an equation with 2 quadratic equations. It will only be one of each. So it won't be too bad. Brilliant. Right, let's have a look. So the way how to do this one is you could have made the y's the same by multiplying the bottom equation by 4. So you get 4y minus 4y. Or you could have made it the x, or you could have made the x's the same by multiplying the bottom equation by 2. So you got 4x and 4x. And then you either add if the two signs are different, or you subtract if they're both the same, and then you'll be able to solve for either y or x, and then you'll be able to work out what x is afterwards. So brilliant, it would be 7. And also another way of checking it as well, you could have put in the numbers into the equations to see, once you've worked out what x and y is, you can always put them in to see which one works and which one doesn't. So well done for the top 5 who got those correct. Right, next one. Using the graphical representation below, what is the solution to the simultaneous equations? So have a look. How do we solve simultaneous equations by graph? So someone asked, can there be more than 2 simultaneous equations? Not a GCSE, no. It'll only be 2 equations. Someone asked, will you be asked to use quadratics to prove something? If you're doing the higher paper, yes, you could be asked a proof question with a quadratic. Brilliant, x equals 3 and y equals 0. If we have a look at that, where they cross, that is at x equals 3 and y equals 0. So brilliant, and well done for those of you who got that one right. Well done for the top 5. Right. So next one, solve the simultaneous equations. So the last one, it didn't cross at 1.5. It was between 2 and 4. Halfway between 2 and 4 is 3. So everyone have a go at solving this simultaneous equation. You've got just over a minute and a half. Also, guys, when you are solving graphically, make sure to look at the axes very carefully. Right, some of you are asking, have I always wanted to do maths? Not really, actually, which is surprising. I only really wanted to do maths after I did it at A level. I didn't actually know what I wanted to do at uni until I got to like year 12 / the ending of year 12, beginning of year 13 sort of time, which was really last minute, but right, someone was asking about that gold rings and pear tree question. Was it asking for the total for both or for one? It was asking for one. So the cost of one gold ring and the cost of one pear tree. Sometimes these questions are a little bit hard to understand, but usually the way how they format the answers as well should help you, because they'll usually have gold ring equals, pear tree equals, and then you just put down the values for those. Right. Brilliant. So remember, you want to make either the x is the same or the y is the same. You could have multiplied the second equation by 2. You would have made the x is the same, and then you would subtract the equations and solve for x and y. Brilliant. Well done, and well done for the top 5. True or false, the solution for the simultaneous equation is x equals 3 and y equals 2. Is that true or is that false? So someone asks, how would you know the word problem is about a simultaneous equation? They'll usually give you when you're forming the equations, you should be able to form 2 equations. If you end up with 2 equations, it is a simultaneous equation. So always form the equations first rather than trying to figure out which type of equation it's going to be. And then once you form them, you should be able to figure out how to solve it. Brilliant, it is false. have a look. We've got x equals 2 and y equals 3, not y equals 2 and x equals 3. So brilliant for you guys who spotted it. Well done for the top 5. Right, next quiz is worth double the points. How much do 2 brushes cost? Be careful with this question. Not only do you, just a little hint, not only do you need to solve it, form the equations and solve it, but now you need to tell me how much do 2 brushes cost, not 1. So be very careful with that one. So someone asked me what grade did I get in GCSE maths. I got an A star, so I didn't have that like level 1 to 9 stuff. I did my GCSEs quite a while ago. Thank you. So someone did ask, what is the difference between doing maths A level and dropping it after 1 year and doing the 1 year maths A level? So I'm assuming you mean doing AS, because in year 12 you do your AS level maths, and then in year 13 you do your A level maths. AS, I'm not too sure. I know that they've changed the way how they're doing it now, so I don't know whether you walk away with an AS level or whether you actually have to take the 2 years and get an actual A level classification. I think it's more linear than modular. What I mean by that is that if you want to get an A level in maths, you have to do both years. You can't just do 1 year. So you have to make sure that you do talk to your teacher about that. But the difference is in year 12, you learn a little bit less than you would at the end of year 13. So you would have less knowledge in that respect, I guess. Right. Let's have a look. So form the equations, you get 3x plus 4y equals 23 and 2x plus 3y equals 16. You make either the x's or the y's the same, and then you go ahead and solve. And you should get 1 brush costs £5, because remember it's the brushes and not the tins that I wanted. So the brushes should cost £5, and then I want 2 of them, so it would be 10. Brilliant. So well done for the top 5, and we're on to the last question. Which method is not suitable for solving simultaneous equations? Which one do you think it is? So someone asked, did I do mechanics or statistics for my A levels? So because I took my A levels a while ago, I could choose one of them. I chose statistics because I liked it a little bit more. Brilliant. Pythagoras theorem. Pythagoras theorem is for solving triangles. So to solve simultaneous equations, you could use the graph like what we went through. You could do substitution, which is for the higher students, or you could use elimination, which is for the standard simultaneous equations. So I hope everyone enjoyed it and they understand simultaneous a little bit better. Well done for 3rd place, Jay. Well done for 2nd place, Kessia, and well done for 1st place, AM. And well done for the runners up as well, Nahanda and Lily. Tomorrow we have our last session at the same time, 12:15, for quadratic equations. I hope to see you guys there. There will be some stuff for foundation students, some stuff for higher only students. And we'll go through a little bit of a recap on simultaneous equations as well. But I hope you guys have a good rest of the day, and I will see you tomorrow for our final session. Bye, everyone.